Okay, we will continue. We'll talk about the last part in our lesson, which is about electromagnetic devices. Look at these two pictures. We have here the little boy on the left is pressing on the doorbell on his playhouse. The doorbell is connected to a battery, so it actually rings when he pushes the button. The little girl on the right is using a handheld fan to cool off on a hot day. The fan also uses battery, and the blades of the fan turn in a blur of motion. What do the doorbell and fan have in common? They actually have in common, girls, electromagnets. So we will see that all electromagnetic devices, they use electromagnet inside them. Any device that has an electric motor, such as let's say hair dryer, such as for example washing machine or clothes dryers, any machine that has an electric motor, it contains what? It contains electromagnets. So in this part we will focus about the function of electric motor. What is electric motor? Pay attention. Let's for example use the simplest example. What is it? The simplest example is the fan. Okay, the fan, girls, what do we give it in order to work? We give it electricity, right? So it uses electricity in order to convert it to what? So it uses electrical energy. We provide energy, electrical energy, to the fan. Then the fan, it converts this electrical energy to what? When the blades turn. What is this type of energy called? It's called kinetic energy, right? When the blades turn. We can say kinetic, or in general, more general, we can say mechanical energy. So what is the role of electric motor, or how can we define electric motors? Electric motors, girls, they just convert the electrical energy given to them to mechanical energy. So when you forget the definition of electric motor, just remember a fan. It is the simplest example of an electric motor. Okay, so the blades of the fan, they turn when we connect it to the electricity. Okay, so when we turn it on, when we give electrical energy, this electrical energy, it's converted to what? To mechanical energy of the blades. Before we talk about electric motor and the function of it, I want to talk with you about something called galvanometer. It's not hard, but you just have to pay attention with me. See, girls, inside the galvanometer, we have electromagnet. I will remind you, what is electromagnet? Electromagnet is a long coil of wire wrapped around an iron core. Okay, so it's like solenoid, but we insert inside it what? Iron core. Okay, so this one is the electromagnet, the one here inside. This one inside, it is the electromagnet. Okay, and there is a needle here connected to this electromagnet, and there is a scale. Okay, around this electromagnet we have a permanent magnet. Permanent magnet, and you know, girls, any permanent magnet, what does it have? It has a north pole and a south pole. Okay, so these are the elements of the galvanometer. So it's made of an electromagnet in the center, and there is around this electromagnet a permanent magnet for sure. So it has like, it's like here one north from a side and south pole from the other. Okay, how will it work now? When this coil is connected to a power supply, okay, to a source of electricity, the current will flow, right or no? The current will flow through it, so we get an electromagnet. Okay, when the current flows, what will happen, girls? This electromagnet, it works exactly, we said, as what? As a magnet. It means it has north pole and south pole from the other side. Okay, so when the current flows through the coil here, through the solenoid, okay, in which we inserted an iron core, so this electromagnet will have north pole and south pole because it will work as a magnet. So now, like, you have electromagnet and around it magnet. So this electromagnet has north and south, and here I have north and south. What do you expect? What do you expect, girls? Here we know that when we bring two magnets near each other, their magnetic fields will interact. It means, like, when you bring two magnets near each other, the opposite magnets will the opposite poles of these magnets will attract. Okay, it means that this north pole will turn to be attracted by what? By north? No, it will turn to be attracted by what? By the south. So as a result, this electromagnet turns. So when it turns, the needle also what? Turns, and shows what? A specific reading on the scale. So this is how a galvanometer works. A galvanometer is an electromagnet that interacts with a permanent magnet around it. Okay? The stronger the electric current, for sure, girls, the stronger the electric current that passes here, what? It means the stronger this electromagnet will be, the stronger the magnetic field it will create. Therefore, it will rotate more, okay? And the reading will be more. So the stronger the electric current passing through an electromagnet, the more it interacts with the permanent magnet. So how can we define the galvanometer? It is just an instrument that measures current. It's just an instrument that measures current. A galvanometer so includes a permanent magnet, an electromagnet that rotates against a spring, and the scale that gives measurements of the current. This is everything for galvanometer. Now, the electric motor, if you understood the galvanometer, you will understand this one. It's very easy also. Pay attention with me. The same thing, I have here what? I have here electromagnet. What is electromagnet? It's here a long coil of wire wrapped around an iron core. Okay? So, with current inside it for sure. So this electromagnet is connected to what? To battery. So current is here provided. Okay, the current flows. When the current flows, so this, it's called electromagnet. Why? Because it will work exactly as a magnet. So it will have north pole and south pole. Okay? So the same thing around it, what do we have? We have a permanent magnet. Permanent magnet, what does it have? North and south. So what will happen? These two magnets, they will interact together. This electromagnet will turn until what? The opposite poles attract. See, I have all the steps here. Okay, so this is the first thing. A battery causes an electric current to move or to flow through the coil of the electromagnet. Okay, so this electromagnet has north and south pole. Now what will happen? Because we know that unlike poles of two magnets attract each other and like poles repel, so this electromagnet now will turn. This north will be attracted by what? By this south. Okay, so it will turn to be in this way. So north is here attracted by south, and the south here is attracted by this north. But now, girls, do you expect that this now they will turn and now they will stop then turning? If they stop, it means that the blades of the fan, they will work a little then stop when we connect the fan or when we turn it on, connect it to electricity. So this is not the case. We know that the fan keep working when it's connected to a source of electricity. So here we need something extra that we didn't talk about it in galvanometer. So till here it's the same concept of what? Galvanometer, the same steps. But now in electric motor, how is it how does it differ from a galvanometer. For electric motor, we have something called, we have a small device called commutator. What is commutator? Commutator is like these two rings that you can see, and we have like brushes connected that connect this ring to the electromagnet on each side. Okay, what is the role of the commutator? We will not go in the details of the commutator, but you have to know its role. What is the role of this commutator? This commutator, it changes the direction of current when the electromagnet makes half rotation. Now see, the electromagnet was like this, right? Then it turns and becomes vertical like this when the unlike poles attract. So now when the unlike poles attract, I don't want this electromagnet to stop because I need my device to keep working. So I need this electromagnet to keep what? Rotating, right? To keep rotating because it's connected to the blades of my fan. Okay, so what is the role of this commutator now? This commutator, when this makes half rotation, it changes the direction of current. For example, if the current was moving from here to here, it will move in the opposite way. Then it will move from here to here, from bottom to top. Okay, so the commutator, it changes the direction of current every half rotation. Why? Because, girls, when the direction of current that passes through the electromagnet changes, the poles will change. This will become north and the one down will become what? South. Okay, when the direction of current that passes through this electromagnet changes, the poles also will reverse. The poles also will reverse. So here suddenly, so the one that was north pole, it becomes what? South pole. And south they repel, they don't attract. So this will cause the electromagnet to continue rotation until it's attracted by what? See, until it's attracted by the north here. And once it's attracted by this north, also the commutator, what does it do? It changes the direction of current. So this again becomes north and the one below becomes what? South. And again the same thing happen. Okay, and this causes the electromagnet to keep rotating in one direction. Therefore the blades of the fan will keep rotating in what? In one direction. Okay, let's read the steps together. So first step, as I told you, a battery causes an electric current to flow through the coil of electromagnet. Part B, or number 2 step, unlike poles attract each other and like poles repel. This causes the coil to rotate until opposite poles are next to each other. Now, if the current in the coil is switched or reversed, and this is how the current switches or reverses by it reverses by the function of the commutator. The commutator, it's what makes the current reverses. So the direction of the coil's magnetic field also switches. The north and south poles trade places. The last step, the coil is repelled and attracted once again to the poles of permanent magnet. The coil rotates until it's again aligned with permanent magnet field. Okay, so this is the electric motor. So in this section you learned about these concepts. Electric motor, so it's a device that converts what to what? Electrical energy to mechanical energy, just as a fan. Electromagnet is a coil that, what does it have inside it? It's not a coil that nothing inside it. If it's a coil only with nothing inside it, then it's called solenoid, not electromagnets. Pay attention. When we say a coil that has a soft iron core inside, so what do we call it? We call it electromagnet. So this electromagnet, it works exactly as a magnet when the current passes through it. Galvanometer, an instrument that detects, measures, or determines the direction of small electric current. Solenoid is a coil of wire only with an electric current inside it. So here you have some extra questions at the end of the presentation.